Hello, everyone. Welcome to the grand finale presentation of the Hamoye Data Science Internship Winter 2023 cohort, brought to you by Hamoye. My name is Mercy Okwadokun, and I am an editor at Hamoye. I'm joining you from Ibadan, Nigeria, and I'll be your host for this session. The mission of Hamoye is and has always been to develop an army of problem solvers through our internship-style training in data-centered careers. We pride ourselves as having been successful with this mission, and it gives us even more joy to have interns in the Winter 23 cohorts perform machine learning wonders from different domains, including security, gender, health, etc. Our interns got the chance to work in cross-functional teams on these, what we call capstone projects. They selected topics of their choice, sourced for data sets, explored them, provided insights, built and deployed models, and are now ready to share their findings with you. In a very special way, I'd like to welcome our members of the different data science communities here present, Hamoye Fellows and Hamoye Internship alumni, and our incredible interns who have made it this far. A big congratulations to you for the great and excellence you've displayed so far. Well done, guys. I'd also like to welcome our judges, Biodun Awojobi, who is a customer engineer manager at Google and an adjunct professor of cybersecurity at the University of Dallas, Texas, USA. Biodun is also a creative technology architect, cloud computing expert, and an amiable mentor. Hello, Biodun. Thank you for joining us.
Thank you very much.
And welcome. Thank you. Glad to be here. Also, we have Wale Akinfaderi, who is a data scientist at Amazon, an expert in machine learning, deep learning, statistical experimentation, and general information theory. He consults for startups in the data science and artificial intelligence space. Thank you for joining us, Wale. I don't know if he's around yet. Is Wale here? Okay, I'll just move on to Peter. Okay, so we also have here with us Peter Iroja. I don't know if I pronounced that well. He's the CIO of Pyro Labs, a company which helps clients to migrate to fully cloud-native business analytics solution. He loves automation, orienteering, and learning about new technologies such as AI. So I'm going to introduce my colleague here, Christian, to carry on with the presentation from here on. But just before we go into the presentation, Christian, are you there?
Yeah, Mercy.
All right, please carry on with the presentation. Thank you very much. Welcome, everybody.
All right, thank you very much, Mercy. Before moving on proper to the presentation, please take note of the following information. Each team will have only 7 minutes for their presentation. You'll be given a warning to round up at the 6th minute, 30 seconds mark, and stop once presentation at its allocated time. That team will forfeit their presentation. At the end of every presentation, we hand over to our judges for their questions and comments. So feel free to use the comment section for your comments and contributions. And finally, dear presenter, try your best to be concise and straight to the point. Remember, you just have 7 minutes. So I hope you've gotten that information. So without further ado, welcoming the first set of Remark and Olaika Akirikon. I hope I pronounced that well. You have the floor now. You have 30 seconds to set up. If you're not available, we'll move on to the next team. Are they here, Ekemong and Olaika? Team base. If they're not available, we're moving on to the next team. Okay, moving on to the next team, Team Django. We have Harish and Tolulokwe, are you available now for your presentation? Okay.
No, he started. May I start or he will continue?
Should we go ahead? I think the other team, they were about to proceed.
Yeah,
Sorry, Team Django, you have the floor now. You can go ahead. They will present last.
okay, we have to start now. Okay.
Yeah.
Yeah, that's perfect. So, hello everyone and the jury. So we are working on the global household electrification. If you can see, there is a presentation, the how much we are going further than there is a further process with the problem treatment, research flow, and exploratory data analysis, feature engineering, model training and evaluation, and summary of model, and then conclusion. Then we go further the problem statement. The problem statement is to identify the features to the contribute to the electrification initiatives of countries around the world. And we have our motive to building the machine learning model to predict the electrification initiatives of countries. Then next we start how we are to elaborate the process. The first we go through the prepare the data, then the insight of the data with the help of exploratory data analysis. Then we go data cleaning, then feature engineering, sorry, and the part of we have to training the model and evaluate. Then we go further, then we what about the data we are working on there? If we can see there, the data is a household electrification. If there is a data available to 124 non-AED, ETD countries, going back to 1960. Of some countries, in most cases, the data cover rural, urban, and aggregate electrification rate. If you go to the link, you can access the data of the source where we have downloaded, and there are features we can see the electorate total and the country name, country code, and electorate urban and electorate rural area, sorry. So these six features are elaborate the how which we introduce the data insight from the electrification throughout the countries where we are working. Then we go further. Then if we see in these data, we can find out some insights. The left side, you can see the box plot where the target variable check the outlier. So there has no outlier available in the data set. So the right side, the histoplot graph, their distribution of the rural electricity rate after handling the missing data. If you can see, there is some skewness and the distributing skewness the data, and this is our target. We can see that. Then we further go. Yeah, this is on the distribution urban electricity rate and after handling data. This is the urban. If you can see, there is the right skew data, the distribution of the data, and then we can back so can you back, yeah, that down the rural area. If you can see, there is an left side between us, so we can find out there is so much differences between the urban and the urban and rural areas. Okay, then further we can go. Then if we strong correlation, the positive correlation, the outlier majority data points, clustering the data about the straight line. If you can see, there is a rural area, so much needs to have, we have utilization of electricity, but there is a less amount of electricity available for requiring the fulfill their requirements. Then we urban, we can see the positive variables clustering straight line. So there have so much variation between there the thing. Yeah. So continue, Tolu.
Okay, thank you. So from what he said so far, exploring the data, we're able to see that there was a strong correlation between the electrical rate of electricity consumption rate in rural and the urban area. And we're also able to see that there was a strong positive correlation between the total electricity consumption in both in urban and total, and in rural and in the total. So what we saw from the heat map was that there was multi-collinearity. So we had to drop the electricity consumption in urban area because it was highly correlated with that in the rural area. So we decided to leave that of the rural because its correlation with the total was quite high. We also dropped the year feature because we saw it didn't have much correlation with the target variable, which is the total electricity consumption rate. Okay. All right, so we selected the country code. I mean, we dropped the country code because we saw that it's basically the same as the country name. So we decided to drop that feature. And we also dropped the electricity consumption rate in the urban area because of multi-collinearity. So we went ahead to split our data into 70:30 using cross-validation as model, cross-validation, yes. So we trained our data with 70% and then we tested with 30%. So we made use of 4 different models: logistic regression, decision tree regression, random forest, and support vector machine, because this is a categorical distribution. So what we saw was that our random forest performed best with an accuracy score of 0.85. So we went ahead to improve our model using grid search CV, and we were able to get the best parameters to then further train our model with, or further fit our model with. After conducting the model improvement, we went ahead to carry out a classification report and confusion matrix, and we saw that our model was able to predict true positive of 141 instances, false positive 20 instances. Also, we had 22 instances that were incorrectly classified as negative, that's false negative, and we had true negative instances of 128. So that showed our model actually performed quite well on the data. We deployed our model using the Streamlit framework that was built using Python. So if you actually go through this link, you'll be able to use our model to predict what the electricity consumption rate would be in different regions around the world, because the aim or the purpose of this particular project was to identify areas that have low electricity consumption rates around the world. So in summary, our model performed quite well with an accuracy score of 88%, and we're able to improve it using grid search CV. We're able to optimize and get the best parameters. And we were also able to identify the areas, like we're able to deploy our model and then identify areas that have low electricity consumption rates. We also found that it was specifically the rural areas that had a low electricity consumption rate compared to urban areas. It is our hope that from this particular project and this research that has been conducted, that the right industries or the right people will be able to make use of the data to further improve electrification around the world. Thank you.
Okay, thank you very much for that wonderful presentation. Moving on to the judges, if they have any comments or questions, Biodun and Mr. Peter, do you have any comments or suggestions?
Great job to the team. Quick question for you. What's your area of future work? Like, what do you want to do next? How do you intend to do further?
All right, so for me, thank you. So for me specifically, I would like to apply data science in the education industry to use it to generate insights that could improve students' performance. So ed tech, I'm interested in ed tech, specifically with the use of data to improve students' performance.
I may have asked the question wrong. What I truly meant, I may have asked the question in a different, I may not have communicated properly, but here's what I really wanted to say. This project around electricity consumption, how are you planning to take it further beyond where you stopped?
Okay, beyond where we stopped. Well, definitely, the particular data set we made use of had 1,035 entries. So that's not a lot of data. So definitely to take it forward, we first of all have to source for more data to actually see if our model performed quite well. So we'd use our model to work with further data and generate more insights, targeted insights, because this was quite broad. We're only giving country names, and we didn't deal specifically with target rural areas. So we'd want to explore further data that would give us targeted insights. The particular data set we worked with was quite broad. So I think working with more data would be what we would want to do. What we'd like to test our model on more data that would give us like more deeper insights.
Okay. Yeah. Are you speaking for the rest of your team, or is that all you guys are looking to do currently?
I know at the start of the project, we thought about sourcing for more data, but we were unable to find the perfect data to use to merge with what we currently had. So, but I don't know if Harish, do you have any additions to make concerning what we could do further with this project?
So what are you talking? Then can you repeat that?
Okay, so he asked what our next steps are regarding this particular project that we conducted.
Yeah. So we have to be looking for the insight to how we develop in the rural areas to be maintaining the electrification. So the how much we have to improvement to the which thing we have to necessarily to be brought out to the urban to rural. So we have to work on that. So we utilize the how much electrification they required properly. The means to what is the seeking behind. So we have to improving through that, and we come up with the insights of the how much we can better in future.
Okay.
Okay. Yeah. I mean, the reason I asked the question is, the only when you have topics like this, or when you're dealing with data, you should look at it from an angle of how do you solve problems with it from the insights that you're gathering. Definitely, having additional data will broaden the validity of the results that you're coming up with. But most importantly, you could start finding problems that are specific to the areas where this data has been collected from and preferring solutions, and maybe publishing something from that perspective. Just like for you all to switch your perspective to how can you truly solve problems, because people who solve problems are the people who become relevant because you are solving problems that's maybe governments or private institutions don't know that exist. But overall, good job. I was just really commenting on to know where you guys are thinking about for next steps.
All right.
Thank you very much.
Thank you.
Okay, thank you very much for that, Mr. Peter, you have any questions or comments today?
Yes. Hi, everyone. I also want to congratulate you on delivering a very good presentation. It's a very important topic, again, because we know there's some discrepancies here, as you've already identified in your presentation. One question I had was, given that, and you might have answered this already, your data is, you said the data you acquired was from 1960 all the way to the present time. And if that's the case, like, how did you deal, or did you deal with issues relating to the different trends associated with the data over time? Because the usage of electricity would certainly have changed over the since 1960 till today's date. Do you think that would have introduced any sort of bias in your data or in your analysis?
Okay, thank you for the question. So yes, our data spans a very large period, and that was why we did a heat map to see what the correlation was between how electricity consumption rate had been changing over time. And it was actually quite funny because there wasn't really any significant, I don't know, maybe it's the data we made use of, but there wasn't actually any significant change. The plot wasn't included in the slide, but there was a plot where I don't know if time permits me, I want to reshare my screen to show you our actual work, if that's fine. We saw that there wasn't actually that much of a difference with how electricity consumption changed over time. So I don't know whether it was the particular data set we made use of, but that was what I observed. Now, over time, there wasn't much of a difference in electricity consumption.
Okay, that's fine. I mean, the fact that you did some analysis to check that, I think it's okay. It's very likely maybe there was something issues with the data, but that answers my question. Thank you very much.
Okay, all right, thank you.
Okay, thank you very much, Mr. Peter. Mr. Wally, have any questions for them? Or
yes, I do. Can you hear me?
yes, we can hear you clearly.
Okay. Yeah. Good morning,
Good.
guys. Thank you for the presentation. I think this is a very important topic to research and sort of derive data-driven insights from. So that's good. My question, the first thing is, I'm still trying to wrap my head around what is your target variable in this project?
Our target variable was the total electricity consumption. The total
electricity consumption, and this is in units, right? So this is in what,
in
kilowatt
percentage?
hours?
No, in percentage total. It was in percentage. Or the percentage.
So it's in percentage. So which means
Yes.
you have between 0 to 100%. So
Yes.
That means that you could actually say that your output variables are actually categorical variables, right? They're not categorical. They're continuous actually, because they're from 0 to 100.
Yes.
Okay. Yeah, so the reason why I'm asking is if they're continuous, it seems like you guys have actually treated these as a classification problem.
Yes.
And not a regression problem.
Yes, because our goal was to predict whether the electricity consumption, like to identify areas that have low or high. So we set a threshold value of 0.5 of like 50% as the threshold. Below 50% was categorized as low, while above 50% was categorized as high. We did this because when we checked to see if our target variable was balanced, and we saw that it was. So that the distribution it was balanced. So
that answers my question. So you guys took the sort of continuous target variables, and then you actually binarized it and sort of turned it into a binary problem. Okay, thanks. I think that answers my question. Thank you so much.
All right, thank you.
Okay, thank you very much, judges. You can stop sharing your screen. We're moving on to the next team, Team Flask. We have Dolapo and Adeshetu. Are you ready? Team Flask. You have 30
Hello.
seconds.
Yes, we are here.
Okay.
I'm trying to share my screen.
All right, your time starts now.
Okay. My name is Dolapo Idowu, and together with Adeshetu Akinwe, we'll be presenting the place of AI in tackling malaria in Africa, the capstone project for Team Flask. These are our team members, and we'll be following this outline. Introduction. Malaria is a life-threatening disease caused by the Plasmodium parasite. It is transmitted to humans through the bite of female infected Anopheles mosquito. According to the WHO, Africa carries the highest burden of malaria cases worldwide. As at 2021, there were 247 million cases and 617,000 deaths from malaria worldwide. The decline in malaria incidence has been attributed to several factors, including increased funding for malaria control programs, expanded use of insecticide-treated bed nets, improved diagnostic testing, and effective treatment of malaria. The aims and objective of our study. The primary aim of this project is to determine how AI can play a significant role in disease surveillance, vector control treatment, diagnosis, the public awareness, and the eventual eradication of the scourge of malaria in Africa. In details, from this project, we hope to develop an AI model that will be used to accurately predict malaria incidence rates and to assess the impact of improving sanitation and water quality. We also hope to contribute to the efforts to reduce malaria in Africa. Our methodology. Data was collected, it was cleaned, we performed exploratory data analysis, our model were trained and evaluated. We also deployed the model for public use. For the data collection, the data set for this project was sourced from Kaggle. We got data from 54 African countries and it contained 594 rows. The data was cleaned, some columns were renamed, and we also created some features to help in our modeling. The null values were replaced, and from our exploratory data analysis, our findings, the figure above shows a pie chart showing the regional cases of malaria in Africa. From this pie chart, the north and south regions were found to have the least incidence of malaria, while the east region of Africa had the highest incidence with 49%. Also, this scatter plot shows a strong correlation between the incidence of malaria and the malaria cases reported to the nearest health center for any given region within Africa. Also, the bar chart here shows the top 10 countries that had the highest cases of malaria. And from this bar chart, the Democratic Republic of Congo, Mozambique, and Burkina Faso had the top 3 highest cases. My co-presenter will be following from here.
Thank you, Dolapo. Standing on the existing introduction, so this is our model training and evaluation. Data set was scaled and split into a training set of ratio 70-30. 5 regression models were considered in the course of this work, namely linear regression, support vector regression, lasso regression, ridge regression, and random forest regressor. The model was evaluated using the root mean square error and the R-squared scores. Hyperparameter tuning was also carried out on the random forest regressor using the random search CV. So our preferred model was a random forest regressor with an accuracy of 85%, as demonstrated on the slide. Next slide, please. Next slide. Our findings also indicated that basic sanitation and drinking water had the highest impact in predicting malaria case occurrence in Africa, as seen on the figure on the screen. One of the key reasons for the decline of the incidence of malaria has always been the use of insecticide-treated nets. And as we can see, as indicated on the charts, it came with a very low ranking. So down to our results, it was observed that those to the east were the most susceptible and recorded the highest number of malaria cases. So a general increase in the incidence of malaria also tend to lead to an increase in the malaria cases, as both were correlated. Basic sanitation and drinking water also have the highest impact in predicting malaria case occurrence in Africa. Next slide. Down to our recommendations. So the use of insecticide-treated nets and intermittent preventive therapy, and also the use of anti-malaria medicine for children under 5 should further be encouraged to reduce the scourge of malaria. Government and health organizations should focus on providing communities with safe drinking water sources and improved sanitation services to help reduce the incidence of malaria. So research should also be further conducted to garner more insights on ways to tackle the incidence of malaria. Next slide. So our model was also deployed using Streamlit, which is a Python package, and it can be accessed via the link on the screen. So for a few seconds, my co-presenter will demonstrate the usage of the model to make predictions. Next slide, please.
You have 40 seconds more.
Next slide, please. Okay, down to our conclusions. So as you can see from our exhaustive methodologies and recommendations, AI does have a place in tackling the malaria scourge in Africa. We do hope it is ready to take that place because we are. Next slide, down to our references. These are our references, and thank you for listening.
Okay, all right. Thank you very much for that presentation. Okay, our judges, I suggest you have questions for them. Mr. Peter.
Hey, thank you very much. Again, another very important topic. Just some questions because unfortunately I wasn't able to infer your conclusion other than the fact that I know that you said East Africa has the highest number. I just want to hone in on that data cleaning. How did you, maybe can just elaborate on how you cleaned your data set just a bit more? I know you said you replaced certain values and you renamed columns. How did you do it in a way that it did not impact the lineage of your data set?
Well, thank you. So from the exploratory data analysis carried out on the data sets, so which consists of 27 columns and 529 rows. So we noticed that the majority of the columns have missing values. So we had to refill them with zeros in order not to affect the accuracy of the data. We also did a feature engineering on a data set by grouping countries into regions so that we can have a sort of regional analysis of the spread of malaria across regions of Africa. So we also add some data types like the year converted to integer data type. So those are the measures we took to actually clean this data.
Okay, thank you. And my last question is just regarding you said you used R-square to sort of determine the accuracy of the models. Do you have
We used R-square and root mean square.
Okay.
Yes.
Do you have the figures for this? I mean, you said you settled on which model and you have it at 85%. Okay. So you settled on a random forest
regressor.
Okay.
Yeah.
Okay. Thank you.
Thank you.
And congratulations again.
Thank you, sir. You're welcome.
Okay, thank you very much, Mr. Peter. Mr. Wale, you have any questions for them?
Yeah, thank you. I have a couple of questions. Thanks for the presentation. I think this is very important. Especially we know that Africa is actually plagued with with malaria. So I think this is very important. Can you go to slide 13? I think is it 13? Yeah. No, there was a slide where you said maybe something Congo, Democratic Republic of Congo, they have the highest number of malaria incidents or something, I can't remember. That's the slide that I wanted to ask a question about. Slide 15, yes. Yeah, and so just wanted to quickly confirm the x-axis is actually purely the number, or is it the case for GDP?
Sorry, I don't get that.
So what's the x-axis? Is it just the number of malaria cases that they have?
Yes, these are the total number of malaria cases to the scale of 100,000, 10,000 rather. As you can see, DR Congo has the highest number of cases.
Okay, and this
These
is
are the top 10.
aggregated.
These are the top 10 countries in Africa that have the highest number of cases, and most are domiciled in East and West Africa.
Africa from the report. Okay. No, I was just wondering what this plot would look like if we have to sort of rescale it and have instead of the total number of malaria cases, probably have malaria cases sort of divide it or try to consider the population of each countries. I was just wondering, sort of, curious what that would look like. So I think that would be nice to have. And then the other question that I have is I didn't really get to see the Streamlit. I know you guys wanted to quickly present. Is it possible to have like the next 2 minutes or so to sort of showcase the Streamlit app?
Yeah, it's possible they can.
Yes.
They can.
Okay, let's do this. Yeah, thank you.
Okay, sir.
I'm sorry for my voice. I've been under the weather this week, so you guys have to bear with me a little bit. Yeah.
No problem, sir. That's fine.
Okay. Okay, can we see my screen?
Yes, you can.
Yes,
Okay, this is a practical demonstration of the use of our AI model. Assuming I'm a health professional or a health researcher or health key stakeholder from West African region, which is coded as number 4, and I would like to investigate the incidence of malaria in my region. I'm selecting for a rural population with 15% population and the use of insecticide-treated bed nets here with 19.67. Also for intermittent preventive therapy treatment in pregnant women as 31.49. And the malaria cases being 46. So I would like to predict the incidence of malaria per 1,000 people that it's as risk in this region. So from this prediction, 289 people per 1,000 population are at risk of malaria in this region.
Yeah, thank you. This is good. This is what I wanted to see. Thank you. And my last comment would be that it would be nice if you guys can actually just going forward, maybe write about the project, have your Streamlit app publicly available if possible, and then you can write like a Medium article about it for more visibility. But yeah, I think this is good. Thank you.
Okay, sir. Thank you, sir.
Thank you, sir. That's noted, sir. Thank you.
Thank you very much, Mr. Wale. Mr. Bill, do you have any comments for them?
I think it's a great project overall, and yeah, great job. No specific comments on my end. Keep up the work. All the comments that the 2 other judges had listed I think are all valid. I would love to see you post this. This is a slider that folks would like to see. When I hear cases like malaria, specifically in Africa, I always reflect on the fact that the malaria problem has gone beyond where it is. So as you're thinking about malaria, you should think about what are the current parameters around malaria. Malaria vaccines are now being approved in multiple countries. And what is the impact of those vaccines with the data that you have currently? And how does that make for the next version of your slider or the next version of how you approach the problem? So if this is an area where you want to focus on, continue to think about how what's happening around you or what's happening around the world in general will have an impact as to the evolution of your project. But that's all from me.
All right.
Thank you.
Thank you very much, Mr. Biodun. Thank you very much. Okay, moving on to the next team, Team GPT. We have Simon and Kayode. Are you here? Team GPTs. All right.
Yes. Good day, everyone.
Right.
Welcome to Team GPT's capstone project presentation. Our project is titled Predicting School Completion Rates in Developing Countries. This is our team. The problem statement. Education is a fundamental human right. As such, there should hardly be a reason for a child or adolescent to drop out or fail to complete their studies. It is shaped by various factors that interact in ways that are complex and dynamic, relating to minute levels like nationwide. In developing countries, many children do not complete primary or secondary education due to various factors such as poverty, conflict, access to quality education. This overlapping mix of challenges requires strategies and interventions to address many factors at the same time. A metric that has been used in the past is the school completion rate. Our approach to this problem was generating the data first, then preparing it and doing some exploratory data analysis, then followed by the modeling, tuning the model and deploying the model. We had to revisit some of these steps in order to improve the development of the model. This shows the sequence. Data generation. Our data was generated from a project on GitHub, Python State of Education 2021, and it was augmented with important features like primary schools with access to electricity, proportion of primary schools with access to internet for pedagogical purposes, proportion of primary schools with access to computers for pedagogical purposes from the UNESCO Institute of Statistics website. Dataset description. The data was made up of different features such as income group, region, country, indicator, gender, year, percentage, happiness rank. Happiness rank is a measure of life satisfaction and happiness of citizens in countries. GDP per capita, primary early. Primary early was referring to the percentage of students that attended school early. Proportion of primary schools with access to electricity, internet, computers, number of attacks on student personnel and institutions, scholarship flow to students, then pupil to qualified teacher ratio in primary education. The data cleaning. The data was cleaned by removing null values. We had a lot of them in this data set. The observations for the data was around 4,200. and and okay, and we had to split the data into primary, lower secondary, and upper secondary so that we can analyze on each levels. Another data cleaning process was imputation of missing data. The income group and region columns were classified. For the income group, we classified them based on high income, low income, lower income, upper middle income. And for the region, it was classified into East Asia and Pacific, Europe and Central Asia, Latin America and Caribbean, Middle East and North Africa, South Asia, Sub-Saharan Africa. And the average was gotten. So we used the average to fill the missing data. Exploratory data analysis. The primary and lower secondary level, as we can see from the charts, are skewed to the right, which indicates that they have higher completion rates, while the upper secondary was skewed to the left, which indicated that they had lower completion rates compared to the other levels. Correlation of features with completion rates. Features like GDP per capita, proportion of lower secondary schools with access to electricity, proportion of primary schools with access to internet, to computers, had positive correlation with the completion rate. Happiness rank and pupil to qualified teacher ratio in primary education had a negative correlation with the completion rate. This chart showed the completion rate. The model training. The model was split in ratio 7:30 for the train and test data. And models like linear regression, ridge, lasso, random forest, and XGBoost were used. And the optimal model was determined based on the R2 score of each model on the test set. For the primary, we discovered that the R2 score for the boost model proved to be the best with a value of 0.917236. For the lower secondary, ridge model was the best model with an R2 score of 0.914639. For the upper secondary, the R2 score for the random forest was the best with an R2 score of 0.841565. Model was deployed and hosted on Microsoft Azure. Conclusion, we were able to build optimal models for predicting school completion rates in developing countries through machine learning. It was discovered that most dropouts occur at the upper secondary level. This may be due to some students lacking financial resources to complete their education or loss of interest in furthering their education. A positive correlation was observed between GDP per capita and completion rate. This means that as the GDP per capita increases, the completion rate rises. The same trend was also observed in the percentage of schools with access to electricity, computers, and internet. This fact was also proved during modeling as these same factors had high important scores. Recommendations. The GDP per capita allocated to educational sectors should be increased by a significant percentage. Fully funded scholarship programs should be brought on to help less privileged students get through school. More qualified teachers should be incorporated into the educational system. Schools should be provided access to electricity, computers, and internet to foster good education. Thank you for your attention.
Okay, thank you very much, Team GPT. Mr. Biodun, have any comments or suggestions for the team?
I just want to start. So where did the GPT come from? Your name, the name of your project?
Okay, the name is just the name they give to each team. It doesn't represent the stack they use in working the project.
I see. I was just curious. Well,
Okay.
This is a very good, I like projects like this, and I'll tell you why I like projects like this, because there are projects that are extremely applicable to many developing countries. I will argue though that there are many factors that there are many factors that affect graduation or completion of education beyond just GDP. But overall, this is a great work that you all have done. I lost you for like 2-3 minutes during your presentation, unfortunately. So I didn't really see all of the ways, your methodology and your approach to getting the data. What are some of your other significant contributions beyond increasing funding, having scholarships and all of that? What are some of the other significant contributions, or what are like your biggest learnings from the project?
All right, sir. We, based on the data that we had to use the features to like determine those that really affect the completion rate so that we could use it as a recommendation. So the primary schools and lower secondary schools and upper secondary schools, we also gave recommendations that students should be made to start school early, as that affects the completion rate on a larger scope, like when they get to the upper secondary level.
Okay. So you are suggesting that your study suggests that starting school early and finances are like the most important factors that affect school completion.
Yes, sir. And also happiness rank. The happiness rank of citizens also determines like the completion rate.
Yeah, it would be nice for you to write about this, because I actually have a varying opinion that beyond education, beyond starting school early, beyond finances, there are other things that matter. I mean, I was fortunate, and I use the word fortunate proudly, that my formative years were all in Lagos, Nigeria. Well, it was in Nigeria, just to be specific. And my parents were not like the richest in the world, or neither even the richest in my state. But what I benefited though was from the public school system. Public school system gave me everything that I needed, and I excel in education outside of the country because of the foundation that I had, and it had nothing to do with finances. I would say there are like some other factors that you might want to consider as you start writing about this and studying this topic a little bit more. I see this more like a thing that you can continue to build on. Factors like, what are the value system of society that you students came out from? Like, what are some of the principles and what are some of the known beliefs? Would you say that if you were to conduct a study from folks that are in the north or folks that are in the east, will the study continue to hold true, or will there be some disparities? Definitely a topic that you guys should want to consider digging in and researching a little bit more. But overall, great work. Please write about it, and this is how to promote awareness. Might also help identify areas where funding or scholarships could be needed. I mean, for example, data science, cybersecurity are like where I think the jobs of the future will come from. How does your study have anything to add or inflect on that point? That makes sense. Overall, great work. And I see Kayode has his hands raised.
Thank you, sir.
Okay, sir. Good afternoon. I don't know if you can hear me. Can anyone hear me?
Yes, we can.
Okay. First, I wanted to answer the question concerning other factors. First off is that we had the issue of generating data because it was quite hard to generate data. So we looked at the problem in the sense that we can approach it in 2 ways, whether on the student sample, as a student sample, or as a country-based sample, because it was given us as a goal that we should go with developing countries. So we decided to start off the project with based on countries, like suggesting based on countries. Okay, on a general view of everything, what is the completion rate? What is the average completion rate for a particular country? So we did this project based on countries, and I believe one of the things that we want to look forward to is making it a student-based project, in the sense that we want to predict based on students whether a student will be able to drop out or not. But for these projects was based on the country. Okay, based on this country, okay, let's say on an average, the completion rate should be this.
Yeah, thanks for the explanation, and I understand. It makes sense.
Okay, thank you very much, Mr. Biodun. Mr. Peter, have any comments or suggestions today?
Oh yes. Once again, to very, very important topic, and not to beat around too much. Two things I just wanted to I want to clarify, and you said you generated the data. Does that mean you just used some parameters to generate the data, or was this yeah, that wasn't clear, because I don't remember you talking about cleaning data. So can you just clarify, this is data that you generated using parameters? So I think
okay,
yeah.
Okay, yeah, thank you very much, sir. So like at the start of the project, we didn't really have access to ready-made data. So what we had access to was a project that did something like this. So they had a data set. So but the features that were there were not we didn't see the features as compelling enough. When I mean compelling, like we don't see the features as contributing enough. So based on that, we referred back to the UNESCO Institute for Statistics, and we, based on the indicators, because the UNESCO Institute for Statistics have indicators for SDG4. So based on it, we were able to pick long formats of some data sets. So merging them together, that's what we term to as data generation, based on the fact that we didn't have a ready-made data whereby we have all the features on ground.
Okay, thanks for clarifying. And the second question I had was around your choice of deploying to Azure. Can you just shed some light around how you decided to, I mean, first of all, thanks for using the cloud, because I think, there's Streamlit and there's a few other things there, but it's interesting to see why you're hosting your solution in Azure. Just, you don't mind answering.
Okay, sir. Thank you very much, sir, for the question. It wasn't really. This is at the start of trying to deploy the model. We tried a lot of things. I think one of the things we tried as a team is using Flask. But we discovered that we had to pay for hosting it on Heroku. So, but talking to one of few friends, they told me that I can use the machine learning Microsoft Azure for free, and so I decided to go for that.
Okay, so you deployed it on the hosted machine learning service in Azure, and that's where you.
Yes.
Okay, awesome. Thank you very much. That's very good and innovative.
Okay, thank you very much, Mr. Peter. Mr. Wale, have any comments for the team?
No, I don't. I think the other judges they actually echoed a lot of some of my sentiments. Yeah.
All right, thank you very much. Okay, moving on to the next team, we have team LightGBM. We have Manju and Frida. Are you on the call? Manju and Frida, team LightGBM.
Hi, sorry, Manju and Frida are here, so I'm standing in for them. My name is Joseph Johnson.
All right, you can start sharing. wants to do that?
Yeah, it's cool.
You also have a lot of background noise. Can you go to another location that you present later if you're not prepared? You have to prepare later, so we'll move on to the next team. So go to a good location that there's no serious background noise. So moving on to the next team, we have team Seaborn. We have Kawu Chong. Are you here? Team Seaborn.
Yes, I am here. Can you see my screen?
Yeah, we can. So your time starts now.
Okay, good. Can I start now?
Yes, you can. Yes, you can.
Hey, good morning, good evening, and good afternoon, everyone. My name is Kawo, and then I'm from Seaborn Group. And today I'm going to present the Homogeneous data science capstone project. The title is about using the diet analysis to predict and also prevent the child malnutrition. So before I go to my presentation, this is my team. I'm the project lead, and also I'm the presenter. And Carl is the assistant project lead, and also Nafisa is the main queries analyst. So our first about child nutrition, we can see here, what is child malnutrition? It refers to a conditions where a child body does not get adequate nutrients required for the growth and also the development. And there are 4 types of the malnutrition. So it is undernutrition, micronutrition, underweights, and overweights. At this project, we focus on 2 types of the malnutrition, which is the underweight, stunting, wasting, and also overweight. The problem that we are going to solve here is we want to predict assessing the diaries, the diets that taking, and also identify the nutrition gap. And also we want to prevent the child malnutrition. The existing solutions here, we have 2. WFTP is a World Food Program which using the satellite image and also the machine learning algorithm to predict the malnutrition rates in the vulnerable populations. Another one is a NutriPhones, which is a mobile apps that using the machine learning algorithm to analyze photos and also meal to provide the nutrition advice. So based on these 2 literature reviews of the app, we come with our approach, which we use an open exploratory analysis to identify the unexpected patterns and also insight for our analysis. And also the most important thing is a sprint approach. We use it to break it down the analysis. So this is a generals of the machine learning cycle. Data preparations, training data set, we're using regressions models, TensorFlow regressions, and also go to the model evaluations. We're using different types of the evaluations, right? R2 MSE and also the loss and MSQ. So about the data set, we got it from the Hamoye, which we're using the global nutrition reports, and we're focusing on 2 difference of the input and also output. So country diet is our input. We use early initiations, breastfeeding, solids foods. And then go to the outputs. We try to predict the stunting, which means the too short for the age of the child. Wasting is too thin of the child, and also overweight. Go to our EDA. Yes, so like I say, X is our country diet, just now I mentioned. Y is a country burdens, which is stunting and wasting. This is our diet analysis. We found that the solid food actually are the highest percentage that consumes by the child that prevents of the malnutrition, while the breastfeeding is a lowest of the intakes for the child. For the country burden, the stunting, which has a higher score compared to others malnutrition indicators, which the child suffering from too short of the problem. And we can see from the regions, Africa has the most stunting problem, and second is Asia. Around the world, we can see here the overweight issues here happening in Europe, and also the stunting, wasting problem, mostly in African areas, and also as well as the stunting. Yeah. So we can see here from the country, the Ukraine suffering from the overweight, which is the most. The country who suffering from wasting is the Eritrea, and also stunting from the Burundi. For going to our models, we have using two different of the machine learning models. Number first is common machine learning, which we use linear regressions, decision tree regressor, large source rich, and also polynomial features. For this machine learning, we have two highest of the models, which is linear regressions and also rich, which there are to score has the highest, and also the MSE square, mean square error is a lowest error. Going to the second one, we also try to using the deep learning models. So here we have two. One is a common layers. We built 10 units, 100 units, 10 units, and 1 unit with the Adam optimizer to with 100 epoch to see what is the regressions analysis. So we see here at the 20-second approach, actually the models is stop improving, and the loss here and also mean MAE here we got is 7.83. Compared to the convolutional layers, the second models that we use in the deep learning, we use also different layer, but this is applied with the convolution layers and also max pooling. The optimizer we use the same as well, Adams, and also epoch we put 100 epoch. So this is the models of the summaries for this convolutional layer. At this, we add the hundreds of the epoch, we get the loss, and also MAE square is 8.3 error. So this is the plot for the convolutional layer. We got that the actuals and the predict actually has a bit of similars, but compared to training and also the predicting, they are more similar. Yep. So going to the comparison, the common layers here has lower of the MAE scores compared to the convolutional layers, which means the common layers are better than the convolutional layer. So in our summary, machine learning models, we have a linear regression and rich models has a better, and also deep learning is a common layer. We here summarize that child malnutrition is a serious global issues, and it needs the AIs to put it in a context in order to predict and also prevent the child malnutrition. So in our recommendations, the breastfeeding is the most important of diet for a child to prevent the nutrition, especially in the Africa area. And also from that, we also want to increase the efforts to be made to improve the dietary diversity in the regions with a lower percentage of child receiving the food from multiple groups. So in our conclusion, that is our presentations. Thank you.
All right, thank you very much for that nice presentation. Mr. Peter, you have any comments or suggestions for the team?
Thank you. Yeah, also congratulate the team for highlighting another very important topic. Seems like everybody's on a tangent today to bring to light a lot of these key issues, especially with malnutrition. The question I had for you is regarding the data set training and the modeling. You had a slide there where you were showing the key metrics and the model results. Were you implying that the standard models were not good enough? Because I'm looking at the R squared scores and they're very, very low. So was that was that you saying that you're ditching this in favor of the second approach where you use like the common layers? Or maybe I did not understand. Yeah.
Yes, actually that is our approach. We try to use two different of the modeling. One is the machine learning and also one is the deep learning, and we want to compare the result. Obviously in the linear regressions, the R2 square is a bit too low. We try to improve it, but after that we got the same result as well. So that's why we try to make it in the deep learning approach as well.
Awesome. So can you just explain regarding the deep learning models, like what sort of metrics did you use to say or quantify the accuracy of your deep learning model? Maybe you can just shed some more light on that, because I understand why you would have gone for that.
Yeah, sure. So for the deep learning, we use a mean absolute error is same as the mean square error, but it's applied to the deep learning models. So from my presentation slide just now, I also mentioned about for the mean absolute errors in the deep learnings actually is not that good as well. Maybe I think in our data sets, in our choose the selections of the models, we have some of the errors that we need to improve it. Yeah.
Okay, so in a nutshell, you're saying it's not really that conclusive. You still need some more, maybe add more variables or maybe choose a different model. Because I know you've come out with some conclusions, for improving this, but I'm just trying to correlate your conclusions with the model output.
Yeah. Yes.
Okay. Thank you.
Yeah.
And congratulations again.
Thank you.
All right. Thank you, Mr. Peter. Mr. Wale, you have any comments for the team?
Yes. Thank you. Thank you for the presentation. My first comment is around the choice of modeling. So in the first set of modeling that you guys had, where the results were really great, you were using a lot of models, I think it was linear models, linear regression, and then in some cases you were adding penalty to the regression. So you're using lasso and reach and things like that. I just wanted to understand, did you guys sort of do you have some statistical underpinnings that actually led to making that decision? Did you sort of check, so for example, if some of the features are linearly correlated or not? Did you do all that before even trying to do the model? That's one. That's the first question I had. I think I'll probably go ahead with the second one because they're related somehow. But I also noticed that this is a classification problem with tabular data. So you don't have things like maybe images or text or structured data, mostly tabular data. And I was wondering why you guys did not use any ensemble models or tree-based models, or ensemble from tree-based. So maybe random forest or XGBoost, things like that. I noticed that I didn't see that. So is there any particular reason for that?
Yeah, for the first questions, I think I can answer of that. We use the relationships. We try to say it is a positive and negative between the country diet and also the malnutrition indicator. It shows that actually it is positive. And then after that, we try to use the regressions models because we see that when we want to predict the malnutrition, the diet is very important. So we use multi-regressions models to put it in our modeling. So that's why we use the linear regressions, the lasso, reach those kind of the regressions, multi-regressional model. For the XGBoost, we didn't use it is because we try to narrow down our focus on multi-regressional model.
Okay.
Yeah.
And then my third question is, I then saw that you guys you pivot to deep learning models, and I could see two different sets of deep learning models. There's the first one where you mostly had your standard model with sort of dense layers. So you have your neurons in these dense layers, and then you have your output, right? And then there's the other one where you changed everything around, and now you're actually using sort of much more complex deep learning models, because now what you're doing is you're actually introducing the 1D convolutional networks, and where you had like your max pooling and things like that. One thing that I feel was really missing is that the story, right? So for example, why you explained it, perfectly why you guys were using those linear models, but we couldn't say it. And also why are you going from using like the standard, deep learning layers to convolutional networks? And then what are the comparison and the results between these two models?
Yeah, it's a good questions. If you can notice that from this both two of the deep learning models, we actually use the same optimizer, same metric, which is a MAE, and also the same approach. But the difference is the layers. So from here.
Sorry. I know that there's a difference. I can see. So I'm talking about the difference in the output, in the results. That's what I was asking about.
Yeah. So the output has difference in terms of the evaluations, the loss and also the MAE.
So which one performed better?
The common one, the 100 layers.
Perform better than the convolution of the 1D convolution.
Yes. Yes.
Okay. So the more because there's a lesson here for probably everyone, is that we used to make a joke that you don't take a knife or a gun to a fist fight, right? So so the conv 1D, actually looking at it, might be an overkill, because in most cases when you want to use this model, you have like some form of sequential relationship between your data, or you have some form of sliding window, but you don't have it in this case, so it's straightforward. Okay, yeah, I think that answers my question. Thank you.
Yeah, I agree with you. Like normally, not all the complex models could give a good outcome.
Thanks.
Yeah.
Thank you.
Okay, thank you very much, Mr. Wale. Mr. Biodun, you have any comments today?
Yeah, no comments for me. Everything the other judges have said is all encompassing. So great work.
Okay. All right. Thank you very much. All right. Moving to the next team. Thank you. Moving to the next team, Team Theano. We have Samuel and Joan Ezekiel. Are you available? All right. Your time starts now.
Good afternoon. My name is Omojasola Joan Ezekiel, and I'm representing Team Theano in this capstone project titled Forecasting the Probability of a Conflict Arising in an African Country. I'll be presenting alongside Samuel Bangbola, and these are the list of our team, from our team lead down to other team members. Then we have our presentation outline from introduction to summary of solution and conclusion. To start with, crime is a form of violence or illegal act performed by a perpetrator against another in order to cause crime to individual property or goods, which is punishable under the law. A very good example of crime is the one which was observed in Nigeria during the EndSARS protest, in which some protesters engaged in looting public goods, and these acts are punishable under the law by government. Crime as seen in Africa has been on high rise, and one of the major contributors to this is government, individuals, protesters, and civilians. For this project, we'll be looking at 3 problem statements. We want to analyze crime rate and fatality in various African countries, as well as the variation among different actors and actor groups and their contribution to total crime and fatalities recorded. We also want to observe the pattern in trend crime rates over the year from 1997 to 2023, and the factor that contribute to most dominant or differ in top 3 or bottom 3 countries. And lastly, we want to build a crime analytical and forecasting tool that assesses fatality threat level based on disorder type, actor and possible crime events, leveraging historical data to inform preemptive policy decision. And this leads us to our process flow for our project, from getting our data set to exploratory data analysis, to data cleaning, modeling and training, then deployment of our solution. Our data is gotten from ASLED, armed conflict location and event data of different African countries from 1997 to March 31st, 2023. These data contain information on dates and location of conflict event, specific type of events including battle, civilian, riot, and protest, events by range of actors, change in territorial control, and reported fatalities. Then we proceeded to exploratory data analysis. We want to visualize what are some of the most common events that have contributed to crime generally in Africa. Then we check fatalities by event type, and one of the most dominant event type is battle, followed by violence. Also, we look at fatalities per actor group, then rebel groups and state forces are the dominant fatalities per actor group. And this leads us to a distribution curve of crime in Africa from 1997 to 2023. As observed here in 2009, there's a steep rise in the crime level in Africa, and the total crime committed in 2023, that's first quarter of 2023, is greater than the crime committed in 2011, which indicates that crime in Africa has largely increased over the years.
All right, so continuing from where Ezekiel stopped, I'm showing you a heat map representing the hotspots of crime in 2022. And then we can also see the top countries in terms of crime rates and the bottom countries also in terms of crime rates. So we moved on to do an analysis of the top 3 and bottom 3 countries in crime rates. And from these visualizations, we can see that in actor groups 1, 2, 3, and 4 contributed the most to fatalities in the top 3 countries. And actor 1 contributed the most in actor type 1 contributed the most in the bottom countries. So we can assume that actors type 1, 2, 3, and 4, representing state forces, rebel groups, political militias, and identity militias, are responsible for crimes incurring high number of fatalities. So for our feature selection and engineering, we decided to drop columns, right, with high missing values. So except for admin 1, which had just 2 missing values replaced manually. So we also performed one-hot encoding for categorical features with fewer number of categories, and we used label encoding for other columns that had a lot of categorical values. Then our target variable was binned into 7 categories, and our training set was scaled using standard scalar, and we used principal component analysis to reduce dimensionality from 121 to 98. So we trained our model using the XGBoost classifier from XGBoost model, from Skykit XGBoost model, and then we leveraged the class weight function from the utils module in scikit-learn to compute sample weights based on the target variables distribution. And we use this to fit our model, leveraging the ability of XGBoost to handle imbalance in data sets. So this is an overview of the evaluation scores that we got. This is how the target variables were binned, and we got an F1 score of 0.7 and precision of 0.77. So a brief demo of our solution. So we have our analysis, our forecasting toolkit displaying just here, and then you can decide to choose from dates and select based on disorder type. So you could select political distribution, change to maybe Northern Africa, and automatically select maybe Algeria. You can select this particular location you want to check and then run the model. And from this, it gives you the worst case scenarios. So here we're saying that the predicted fatalities will be 0. Also, that means definitely the best case scenarios will also be 0. It shows you the actors that could cause this number of fatalities and the possible event type that could happen. And this is based on the model. So an overview of our analysis toolkit parts, you can do, you can filter by year and the homepage, check for hotspots in crime, check analysis of crime rate and fatalities, list record of crime, most number of fatalities per country, and the deadliest crime that were recorded in Africa. Then you can also move to analysis toolkit and filter by country. So you can have access to the deadliest crime recorded in Algeria, check the notes like the description of the crime. You could check highest record of crime per sub-national administrative region, and then lowest record of crime, highest number of fatalities. Then you can move on to the top crime actors in Algeria. That's based on, like in that country, based on total fatalities. So the GIA right, has the most number of fatalities committed in Nigeria from 1997 up to 2023. You can check the number of fatalities in their biggest crime and the description of their biggest crime. So this solution was deployed using Streamlits, and then a database, the data sets we use for all this analysis is hosted on Azure Blob Storage. And then everything is in our GitHub repo as indicated here. So we successfully provided a solution to our defined problem statements. We used the preferred data set, like I already mentioned, to train the model. And the crime analytics and forecasting tool was built to access the threat level of fatalities based on disorder types, actors, and the rest of other features we use to train. So the model is based on a simulation based on that, and it simulates event types, actors, and gives you worst case and best case scenarios. So in conclusion, our solution provided a comprehensive analysis of crime rates and fatalities in various African countries with insights into the contribution of different actors and actor groups. So our findings underscore the importance of considering location, time, and actors when analyzing crime to make informed policy decisions. Thank you.
All right, thank you very much for that wonderful presentation. Mr. Biodun, you have any comments for the thing?
Yes, I do. I mean, one thing that I want to say before we even get to the end of the presentations for this particular session is the quality of presenters seems to always be getting better. And I don't know how that has happened, or maybe the cohort is just getting better every time. But I've really enjoyed listening to all of your presentations. Specific to this one,
thank you very much.
Yeah, of course. Your approach and your methodology sounds fine to me. One thing that I would like for you to consider is I always would like for every presenter here to think beyond the data set that you have and understand that the whole concept of data modeling and data science and analyzing data, there is an enrichment capability that you could be tapping into. And have you guys thought about what other enrichment data sets you could be using with the data that you have currently? And what sort of insights or perspective will that enrichment data provide in terms of how to take your work to the next level? So that's my first question. And I'll wait for your response before I go on.
Okay, thank you for that. So the particular data set we're actually using is from Axlet, which is like a project or company that collects data on regular basis. So we leverage theirs, and it's something that we have in our mind that we can always go back, try to create a pipeline where we update the data set that we use for modeling and analysis. And then if we had some extra data set that contained maybe more details into the actual crimes. Like for example, in the data sets, there's some particular crimes that are recorded by day, but you don't actually know that that particular crime continued for maybe a period for like 3 days or 4 days. That isn't really accounted for in the data set. So if you had details of that, maybe for like targeted attacks or sequence of attacks that happened over a long period, because this particular data set just records per day, independently of whether it continued for a long time or it was a war something. So we had something like that to give us better insight on how to like do some analysis or create better models.
Yeah, and let me kind of give you an example, and thanks for your response. Consider a situation where there's a regime change, or consider a situation where the earning potential of people in that particular region is below like the earning potential of the whole country. Like, how does those type of data sets, like educational level or demographic or average earning potential, how do those type of data set influence or affect crime? Because it's from those level of data enrichment that gives you the flexibility, or does your current data have all of those kind of parameters?
No, our current data doesn't have these, but I believe that we had these extra details. It could help us and draw out motives for this crime, and we compare, like you mentioned, education, like illiteracy level and all these things, from movies and other things around us, we see that these contribute a lot to crime. So if we had this, we can actually like draw out some analysis, create a kind of model that shows that, okay, because of like comparing different regions and the amount of crimes, we can see that, okay, because of, majorly because of the illiteracy level or the unemployment level in this country, there is more crime. So it's something that we can actually draw out like a kind of motive or a kind of background to why these crimes could have occurred.
Yeah, I try to make a lot of my commentary outside of just technology, specifically because when you pick a topic, and this is really for everyone that has presented, when you pick a topic, try to fall in love with that topic, because when you fall in love with the topic, you truly want to do something special about the topic. Not only solving like the problem that you're solving, it's more like trying to solve for problems that people don't know exist. And it's in understanding, okay, why does this matter? Why should this matter to government? Why should this matter to parents? Why should this matter to foreign investors? Like when you start thinking in that direction, I would argue that you will create an AI company. Like all of these like AI bots that we're seeing right now, or AI chat engines that we're seeing pop up, the project that you're working on right now could literally be an AI company if you fall in love with the topic. And literally almost all of the presentations that you all have done today could be an AI company if you fall in love with the topic. If you try to search for and solve for problems that nobody has thought about, you'd be surprised how a food data set could make your current project more interesting. So that's the only thing that I would like for you all to consider as you continue to think about it. Definitely write about it and set roadmaps and milestones as you continue to go ahead. But overall, great work, and yeah, keep it up.
Thank you very much, sir.
All right, thank you very much, Mr. Building. Mr. Wale, you have any comments, suggestions for the team?
Yeah, and I think thanks for the presentation. I really like it. And my comment is sort of in addition to what Building said just now. For example, I would like to see what if you have things like social demographic or socioeconomic indices, right, of this different region. If you can take things like education level, what's the unemployment rate, for example, what's the median income. I would really like to see some of this information and see, are they significant in forecasting the probability that the conflict might arise in that region. So I would say, there are a lot of things to explore, and just love your project and see if you can actually explore more. But this is good. Thanks, guys.
Thank you very much, sir.
Thank you very much, Wale. Mr. Peter, any other comments to the team or suggestion?
Oh, thank you. Just like everyone else said, I would have been nice to be able to have more categories, and maybe would have helped with the some of the variable selections that you've had here, because I'm going to be honest, I am actually struggling to find out or figure out what how the model is going to forecast in this case, because I don't actually know what the targets were that you were trying to model. Maybe you can just remind us. Yeah.
Okay. Yeah, let me just briefly share my screen on the forecasting tool. So yeah, our target variable was the fatalities, so like the range of fatalities that could occur, right? And then based on your input, so the date that you expect the crime to occur, and this other type basically describes what is happening around you. A crime hasn't occurred yet, or you have maybe people are protesting in terms of demonstrations, or there's political violence like uproar, rumors, and all that. So you can now tune it down to the particular location and then run a scenario. So it runs a simulation of possible event types that have happened in that region before, and then based on all the features that you selected before, and then compares it with if what actors are involved, and it gives you a pretty range of fatalities. So we have 0, 1, 2 to 10, 11 to 50, and like that. So you have an understanding, and you can do some comparisons maybe with previous years and look at how you can inform or decide on the strategy you want to use to prevent that crime or contain that crime.
Thank you very much. I think I understand now. So it was fatalities we were trying to forecast. Thank you.
All right. Thank you very much, Mr. Peter, for that.
I don't know if you're with me, sir.
Yes, we can hear you. We can hear you, Samuel.
Hello.
Okay, moving on to the next team, Team LightGBM. Are you ready for your presentation now?
Okay. Thank you, sir. Yeah, thank you very much.
Hello. Hi, everyone. LightGBM is ready.
All right, you can start sharing your screen.
All right. Please, can you see my screen?
Yes, you can go ahead. The time starts now.
All right, great. Good evening, everyone. My name is Chato Joseph. I am representing Team LightGBM. We were to work on the animal species detection using deep learning. I'll start off now. So our team we're 6. My name is Joseph. I have other team members that work with me, and some couldn't put their pictures because of size, but they were all very active in the project. And problem statement to our problem. So the decline in biodiversity and animal species population is a critical issue that threatens our world's health resources and sustainability. There are also various methods to monitor animal species, and their populations are expensive. They also require high labor and are also time consuming. Lastly, deep learning models can identify animal species to a reasonable degree of accuracy, process large amounts of data quickly and accurately, and automate the whole process, leaving ample time for developing more effective conservation strategies. So those are our 3 problem statements. Moving on, our objectives of the project. The objectives were to develop more efficient models that can actually perform animal species detection in real time, handle large data sets, and scale to a wide range of species and environment. Second objective was to develop animal species detection models that can contribute to conservation efforts by enabling the monitoring and protection of endangered species, preventing poaching, and promoting biodiversity conservation. And lastly, the last objective was to address the challenges of data quality, bias, and diversity by exploring, by exploring pre-processing techniques, data augmentation, and transfer learning to improve the robustness and generalization of animal species detection models. And our approach, so we followed an agile approach where we had to start from the first to the last steps, and then after we performed the steps, we saw that our model was not quite well, so we had to start afresh again and try the whole approach again on new models. So first of all, we defined the whole problem. We now explored the data. We went ahead to model our data. We tuned the data. We saw the performance of the model. The first model was our baseline model, which was CNN, convolutional neural network. So we had to, the accuracy wasn't really good. So I had to go back again and do the same thing for other models, which you will see coming up. So the process we followed was basically, the first process was to understand our data. We collected the data. The data set was actually on Kaggle. It was given to us by Hamoye. It was on Kaggle. It was already cleaned. So we collected the data. We didn't do anything about data cleaning. We explored the data. Of course, there were image data sets. So we explored the data, we look at the data and all of that. Then we moved on to splitting the data, resizing and scaling it. And then thirdly, we modeled the data with convolutional neural network, which was our baseline model. Then after it performed poorly, we had to go on with transfer learning. We used a few models as VGG and Inceptive V3. And then after that, we moved to model evaluation, where we evaluated the performance of our data and of our models, and then we settled with a model with the highest accuracy. About the data set, as I earlier said, is from Kaggle. There are 376 images for each animal classes. The data set contains 4 classes of animals, which comprises of buffalo, zebra, rhino, and elephant. So for the modeling, we built 3 models. First was a convolutional neural network. Second was transfer learning using VGG16. And the last was also a transfer learning model, Inception tree, V3 model. Now, having worked on the 3 models, the scening gave us quite a low performance. We did so much work on that. But it was our first model, it was a baseline model, so we did so much modeling. We even went ahead to augment the data, and we still had very low performance. And there was also an issue of overfitting. We did a lot of, we used a lot of techniques such as early stopping to control that, but still the performance was really poor. So that was why we had to move on to transfer learning models. We tried VGG16 and gave us a training accuracy of 0.92 and a validation accuracy of about 0.89. Then we also wanted to have better models, something above 0.995. So we moved on to Inception V3, which gave us a training accuracy of 0.97 and a validation accuracy of 0.96, and we settled at this. So the Inception V3 was actually our final model, and yes, these were the graphs, the validation accuracy and that of the training accuracy. And the graph on my left-hand side is actually the lost graph, and the validation and the lost graph of also the validation accuracy and then the training accuracy. Then we moved further. So finally, we had the model. We settled on the V3 model, and this was the accuracy 96.67. And finally, we had a conclusions, which was a session V3 model can recognize the endangered species accurately. The model automates the monitoring process of animal, allowing for more effective conservation strategies. And overall, the project is a significant step towards protecting endangered species. The model developed can aid in identifying these animals accurately in real-life situations. Thank you. That's basically everything we did. Thank you so much.
All right. Thank you very much for that presentation. Mr. Wale, you have any comments, suggestions?
Yes. Thanks for your presentation. I think there is something fundamental that I'm missing here. And I think let me pose it back as a question. Now, let's say you have an image of an animal, which I think you have. If you go to your slide deck, data set description, right? Can you go? Not your data set, your slide deck. Can you go to slide 8?
Okay, slide 8. Here. Can you see it? I see my screen, please.
No, I cannot.
No, we can't. We can't see your screen.
All right. So let me share that. Okay, I'm there.
I think it's coming up.
How about now? Can you see now?
It's loading. Not yet.
Okay. I guess it's network. Sorry about that.
Okay, I can just continue. So when you have an image that have multiple objects in it, right?
Yes, sir.
Let's say you have an image that has that image that I wanted you to bring up in slide 8 has like zebras, for example, an elephant, right?
An elephant here, yes.
What does your model predict in sort of a multi-object scenario like that?
Okay, so actually, we could not actually we didn't deploy the model to actually try it out on similar images. We actually just used the data set offline, and then we just got the model performance based off this thing. So we're unable to actually deploy the model in time. students. Yeah.
No, I'm not even talking about that. So first, a lot of things are missing in this, which is the characteristics of some of the data set or the images that you have. Probably better to show us samples to know, are you classifying on images that has just a single class of animal, or are you classifying on images that has multiple class, right? And so for me, that's where I was a little bit surprised that this is an image classification problem and not an object detection problem. So with object detection, what happens is that if you have multiple objects in the image, so a zebra, a rhino, an elephant, it tells you every single object that there's and then it draws bounding boxes around it, right? And so what it gives you then is that your prediction accuracy in this case, which is the mean average precision, it's a multiplication of the sort of the intersection over union of the coordinates of the bounding boxes multiplied by the predicted classes. So I think this is much more better, especially in the wild, where you can have multiple animals in a frame. So it's better if it's actually posed as an object detection problem instead of an image classification problem. That's the first comment I wanted to make. The second thing also is that I think that's one thing that Builder has been sort of hammering, and it's actually really, really good, is that sometimes, I feel like you guys probably could have, thought about this beyond just classifying animal species, right? Try to find a use case for it, right? Use case would be, for example, you can actually try to tie this with the people that actually do trafficking of animals, for example, in the different areas in sub-Saharan Africa, the Tanganyika, all the different places where they actually go to, they do animal trafficking, and say, okay, maybe having cameras, for example, and taking these images and being able to detect them in real time would actually help, so that if there is an animal migration from one region to another geolocation, for example, you can use this to detect and also count them. So I think, tying it to like a proper use case, I think that would have been nice. So those are the two comments that I have. Thank you.
Okay. Thank you very much, Mr. Wale. So Bill, do you have any comments with him?
Yeah, I actually think Wale's comments were all well-rounded. Like a lot of what I wanted to say, he already mentioned. Another great work, and yes, find your applications beyond this. And hopefully it's a topic you like, and it's a topic you can continue to develop on. But overall, great work.
All right. Thank you very much. Mr. Peter, any comment for the thing?
None for me specifically, but thanks for bringing this to the presentation.
Okay, thank you very much. Okay, now down to our last team, Team Base. Are you ready for your presentation? AK and Olaika.
Yeah, good afternoon.
Okay. Jato, you can stop sharing your screen now. All right. So,
can I share my screen, please?
Yeah, you can. You can.
Yeah, good afternoon, everyone. This is AK of Team Bias. We did our project on remittance patterns and economic development. And these
sorry, we can't see your screen just yet. Still loading.
Okay. Is it on now?
Not yet. I think you have to stop and start sharing again. Stop and start.
Okay. What does that mean? I can't seem to stop sharing. Oh.
Okay.
Hello, can you hear me?
Yeah, we can hear you. Can your co-present? Okay. Stop now. Start sharing again. Or your
Is it sharing now?
Not yet. I believe you have a co-presenter. Can he or she assist you in sharing your screen?
What's happening now? My system is freezing.
What about your co-presenter, Olayinka? Isn't he available to assist in sharing the screen?
Yes, I'm sharing already.
We can't see.
Sorry, can you see now?
No.
I'm still.
Okay, we can see it now.
Okay.
So your time starts now.
All right. So we'll be talking about remittance patterns and economic developments. I'm Olayinka, and this is our project. This is the member of the team that contributed to this project. And then basically, this is the topic of discussion. We are talking about remittance pattern and economic development, the problem statement. So the project seeks to use a machine learning algorithm to explain the relationship between economic development and remittance patterns of country, and to predict the reason for dwindling remittance and how to mitigate against it. So, introduction. According to Investopedia, foreign remittance is a transfer of money from foreign workers to their country, to their own country. And then in this research, we intend to draw a clear line between the impact of remittance on the economy of the country and how it can be of great use to the country. So basically, we got our data. We got our data from K-Nomad, and then we cleaned our data. That means we remove non-value. And we also we did exploratory data analysis, and then we did model training and evaluation, and summary and conclusion. So the description of the data set, we used data from knomad.org and Cargo. So, and then our data contains the remittance inflow from country, then outflow, and then the bilateral matrix, which consists of both the sending country and the receiving country. So the period of our data is from 1990 to 2022, and then 1990 to 2021 for inward and outflow remittances. This data set also contains a percentage of the remittance. So in the bilateral remittance, it shows the flow of remittance from one nation to another, one nation to another, one nation to another. This is our flow rate. So exploratory data analysis, we examine the trend of remittance inflow and outflow over time. We identify the country with the largest remittance inflow and outflow. We explore the relationship between remittance flow and the economics indicator. We identify the sub-region with the largest remittance inflow and outflow, and then we predict the effect of remittance on a country GDP. So this is the EDA. From the EDA, we can see that India as the top country for inflow, and then United States as the top country for outflow. Nigeria also is among the top 10 receiving countries. We use a Seaborn library to plot this visualization. And then we also check the country with the highest inflow as a percentage of their GDP. And we found out that countries like Tonga and Lebanon and Samoa are the countries with the highest percentage of their GDP being the remittances. So with countries like this, it means that any slight variation in the remittances would affect their GDP drastically. So we also did a sub-region group, and then we got a chart of the total inflow by sub-region, and then we also take a percentage by the sub-region. We saw that countries from Polynesia are the ones with, countries like Tonga and Samoa are the ones with the highest percentage of GDP remittance by sub-region. Model training and evaluation. We trained various models on the inflow remittance data, which is the data that shows what percentage of the GDP a country receives as a remittance. And then we split the data on the ratio 8-20, and then we took the Z-score of each column, and that means we use standard scalar function to standardize, and then we fit a model on the linear regression, random forest, extreme gradient boost, root regression, lasso regression, and the SBR and SGB. Model training. The random forest model was better at minimizing losses throughout the project because we are trying to minimize loss. And then we did an hyperparameter training using grid search CV. The random forest showed optimal model results than other model. And we obtained the best parameter as a random forest regressor, max depth 5, max feature auto, mean sample size 4, and an estimator of 50. The best score is lower in the random forest than the SVR, and it shows that it has a better predictive value. This is an illustration of our mean absolute error, our mean squared error, and our root mean squared error. We found out that the random forest was more optimized while calculating those various 3 errors. So in summary, government of countries with high remittance inflow should create policies that would encourage investments in productive sector like agriculture, small businesses, and manufacturing. And also, remittances can be encouraged by reducing transaction costs so that people don't have to go through a third party to send money, and this remittance can be taken into account while calculating the country earning. Then government should improve literacy level of people. So this would ensure that our remittance are maximized for goal-driven projects. Thank you.
All right, thank you very much for your presentation. Mr. Peter, you have any comments for the team?
No, just say well done again. It's another very important topic. Yep. And maybe just one comment around the did you have a demo of this? Like, did you manage to deploy or applicate your model to like Streamlit or somewhere else?
No, we did not.
Okay, that would have been good to be able to, check this out. But other than that, well done. Nothing else from me. Thanks.
All right, sir.
Okay, thank you very much. Mr. Wally, any comments?
Yeah, thank you. I am not entirely clear on the data science part. Because I wasn't sure what exactly are you predicting? What's your target variable? I think I feel a bit lost in
Oh, okay. Our target variable, we use the percentage GDP as the target variable, the percentage GDP of the remittance.
Percentage GDP of the remittance.
Like we obtain that's remittance over the GDP times 100.
Okay.
That is what we used for the target variable.
Okay, thank you. Yeah.
Yes, sir.
Yeah, I think overall, yeah, thanks for the presentations. And to everyone, yeah, thanks for the presentations today. Yeah.
Thank you, sir.
That's good.
Okay, thank you very much. Mr. Biodun, any comment?
No comments from me. No comments from me. Great work.
All right, thank you very much. And with that, we've come to the end of our presentations. Thank you very much for all the teams that are presented so far. But before we go, any final words generally for the teams from our judges? Mr. Wali, any final words for the team on their performance?
I mean, on the performance, I think this is great. Quality was really good. There were, I was really impressed with all the presentation, the work that you guys put in, and then in terms of a lot of the things that we mentioned around, there's always room for improvement. There are a few things that you guys, could probably do better. And I think one of it is defining the sort of problem that you're trying to solve properly. So, or whatever you're doing, you're modeling, tying it to some form of, it could be a business problem, for example. It could be things around, problems that has to do, that can improve, for example, socioeconomic activities. So tying all the fancy modeling and the different ML models and the output of your result and making conclusion and tying it to the different, problems. I think that would be really nice to see. But overall, I think, fantastic job, guys.
All right, thank you very much, Mr. Wale. Mr. Biodun, any final advice for the team?
Yes, thank you. I've enjoyed all of the presentations that I've had the opportunity to listen to and watch so far. I'm going to go back. It sounds like a bit of a repetition, but when you pick a topic, please find a topic that you have a passion about. I share this in some of my classes, and just sharing it with you all as just a nugget. When everybody sets some goals, you doing the work that you're doing right now, the projects that you've all completed, it's like a small goal. You eventually come to a completion, and this is kind of your conclusion for the project, but you could decide for it not to be your conclusion. When your goal is about something that revolves around you, you see it through to the end, and which is what you've done. When your goal is something that's a little bit bigger, it may take you a little bit more time. The constraints might be there. It would push you further. But at the end of the day, you might be able to get there too. You will most likely actually get there. But if you set your problem statement and tie it to what I call a cause, something bigger than you, chances are you may not actually solve the problem, but you would make a dent. To tie your problem to a cause first requires that you fall in love with that cause. It's something that you truly believe in. And I would argue that a lot of the people in this world that we remember and we write about and we read about and we're obsessed about are people who have tied their life's purpose to a cause. I'll give an example. People remember folks like Nelson Mandela or even Elon Musk. People like that they dedicated their lives to something bigger. And by doing so, people will write about them. And in turn, too, they become extremely wealthy. Why? Because people realize that they're doing a lot of what they're doing selflessly, and money will just come by virtue of that. It's a long-winded statement to say that when you find a topic, let it be a topic that you like, and continue to push forward and push the bounds of what's possible or what's not being thought of in around that topic. I would say for one of my very stern observations so far across all of the presentations is that the quality of presentation has been quite solid. It seems to me more like there's been a bit of rehearsal that you all have done. It doesn't seem like you're all rambling, which is like, good job to you. And you can continue to push that further and dedicate your life to continuous learning. But overall, great work. And I look forward to seeing what you all blog, post, and do all of that about.
All right. Thank you very much, Mr. Biodun, for those nice comments. Mr. Peter, any general advice for the team?
Yes, thank you very much. And again, to add to what Biodun and Wale have already said, you guys should be really proud of yourselves for the work you've achieved here. Because these are real world problems that you have, really, stuck to, and you've delivered some solutions for. And I think it's a very important achievement. Just a bit of advice on, where to look to next and what to do next. Like, because these are real world problems, you would need to keep pushing yourselves, and don't be afraid to break boundaries and break the norms with respect to like the different technologies that you can use to solve a problem. Guys already say, think outside the box when you're choosing your variables, and when you're trying to solve these problems, think of the end state. But again, what I would just really hammer on is, don't be afraid to break boundaries, especially with the tech that you use. So that's it for me. Thanks.
All right. Thank you very much. Thank you very much, Peter. So at this point, I'd like to say a big thank you to all our presenters, the teams and judges, Mr. Wale, Mr. Peter, Mr. Biodun, for a successful session. Myself and the rest of the Harmony team are honored to have hosted you on what was the climax of a rather intense 4-month journey in the field of data science. We can't wait to see you soar in your choosing fields. But before we round off, please take note of the following as the intents. The results of the Grandfinale presentation and other information will be passed on the Slack channel in the coming weeks. So do wait to pay an eye and attention on the Slack channel and also on your emails for more announcements. Well, on this note, I'll say thank you very much once again for joining us on this exciting presentation and Grandfinale presentation. On that note, it's a goodbye from me. Do enjoy the rest of your weekend. Bon voyage.